Hello and welcome to Chemistry with Dr. Z. In this video, I will be talking about hydrolysis of esters. Esters are hydrolyzed to form alcohols. Hydrolysis is basically splitting up by water. For esters, the hydrolysis can be catalyzed either by an acid or by a base. So we have the acid catalyzed hydrolysis when you have your ester react with water in presence of an acid. So you reflux it with a dilute acid like dilute hydrochloric acid or dilute sulfuric acid. That will give you the carboxylic acid and the alcohol that formed the ester. So this is the reversible reaction for the esterification, which is the reaction between an alcohol and an acid in presence of acid catalysis or a catalyst of an acid that gives you the ester. The second type of hydrolysis is the base catalyzed hydrolysis. In base catalyzed hydrolysis, you react the ester with a base like sodium hydroxide or potassium hydroxide, and you reflux that as well, and that will end up with getting the salt of the carboxylic acid and also the alcohol. So let's have an example of acid catalyzed hydrolysis. If you have an ester like ethyl ethanoate and then you react it with a dilute acid, so in presence of water and presence of an acid, and you reflux the ester in presence of the acid, that will give you ethanoic acid and ethanol. For base catalyzed hydrolysis, this is not a reversible reaction here, as you can see. So you reflux your ester like ethyl ethanoate in presence of the base, and this is an aqueous solution of a base. So you have water here. So there is sodium hydroxide or potassium hydroxide. Then you're gonna get the ethanoate, which is sodium ethanoate or potassium ethanoate, and ethanol. Fats and oils are esters of glycerol and fatty acids. So one of the main esters that we use on a daily basis are the fats and oils. So glycerol is propanol, propane 1,2,3 triol. So this is a all or trihydroxy alcohol. These glycerols can react with fatty acids, and fatty acids are long chain um, acids which have a long chain hydrocarbon or hydrocarbon long chain. They can react together in esterification reaction as normal, and this is will give you the triglycerides or triester of the glycerol. So the reaction will be the normal esterification where the OH of the carboxylic acid will react with the hydrogen from the alcohol, the three carboxylic acids, three different ones, and that will give you the ester of glycerol. So these are the fats and oils. This is one example of these fats and oil, which are the triglycerides of fatty acids, three fatty acids with three ester bonds. What is the difference between animal fat and oil? So animal fats have saturated hydrocarbon chain, so there is no double bond as we can see here at all, which means these fatty acid chains will fit in together very well, and that will increase the van der Waals forces between the different molecules, and that means that they will need more energy or more heat so they can melt. So this is why we notice that the fats of animal fats are solid at room temperature. On the other hand, oils are unsaturated. They have double bonds, as we can see here, and these double bonds means that the chains are bent and the chains do not pack together very well, which means that there is a reduced or decreased van der Waals forces between the molecules, so they can easily melt, and they are liquid at room temperature. So this is the main difference between animal fats and oils. It's the degree of saturation. Animal fats are saturated, oils are unsaturated. Making soap. So the triesters of the fatty acids, which comes from natural oil or fat, can, if they are reacted with base like sodium hydroxide, in presence and refluxed. This is the that will lead to the hydrolysis of the esters, the triglycerides, and that will make glycerol and will make the sodium salt of the fatty acid. This sodium salt of fatty acid is actually the soap that we use. So soaps have the polar carboxylate group, the sodium carboxylate group, and they have nonpolar alkyl chain, very long alkyl chain. Esters are also useful as biodiesel. So biodiesel are a mixture of methyl esters of fatty acids. So we have the triglycerides of some fatty acids like vegetable oils, like rapeseed oil. They are good fuel for the vehicle. However, they cannot be burned directly into engines. They have to be converted into biodiesel. To convert these into biodiesel, you react them with methanol in presence of potassium hydroxide as a catalyst, and that will give you glycerol and will give you mixture of methyl esters of the fatty acids, which can be used as the biodiesel. So the methyl esters of these fatty acids are the biodiesel that can be burned in vehicles.